Designing and building your home for maximum efficiency is a great way to take control of your energy spending.
Zero energy-ready homes are gaining in popularity, and we're about to give you all the details, including highlighting some features that could be added to your existing home.
Today on PowerHouse, we'll define the ZERH designation and get the rundown on an example in our area.
We'll talk about two specific products that condition air, control airflow, and maintain comfort in your home. Efficiency is the name of the game on this week's PowerHouse.
This amazing home is a brand new example of a zero energy ready home, or ZERH. It was designed for efficiency and built to exacting specifications to deliver as promised. Here to tell us more about the ZERH designation and how this building project came together is Jeff Ralston from Ralston Eco Homes. Jeff partners with builder Todd Richardson to create efficient, self-sustainable homes. Jeff, I am so excited to talk to you today. Let's start with the basics. What is a definition of a zero energy ready home?
First of all, the baseline for a zero energy ready home is to meet Energy Star whole home certification. So, we often think of Energy Star for rating appliances, but they also have very rigid standards for having whole home certification as Energy Star. And then the Department of Energy Zero Energy Ready Home takes that further. So not only are the insulation and energy efficiency requirements higher, they also require us to meet EPA standards for indoor air quality and water consumption. So the ultimate goal is to have a home that's energy efficient, durable, healthy, resilient, and then also allows you to add renewable energy to offset the consumption of the house.
So how did you and your company get interested and involved in this type of construction?
Well, I've spent my entire life in the Midwest. I've seen the extreme weather events that can happen here. And so I approached Todd Richardson Construction and asked if, he thought it was possible to build a home that was more resilient to our extreme weather. I was also interested in building something that would allow people to become energy independent. And so we looked for something that could validate what we were doing, the ideas we had for the house, and the Department of Energy Zero Energy Ready Home certification allows for that third-party independent verification or validation of what we did.
So there are so many moving parts to building a home like this and so many considerations. If a homeowner is interested in doing something like this, how do they get started?
The first thing I would say is that you talk to the potential homeowner, ask them what their motivations are. Are they interested in reducing their carbon footprint? Do they want a house that's healthy, resilient? That's the first step. And then we introduce the homeowner to a home designer and a computer modeler. Because, for what we're trying to accomplish, computer modeling is very important. It allows us to make some small or big changes to things like the size or number of windows, the orientation of the house. And then that allows us to meet all of our energy efficiency standards through computer modeling. That modeling also allows us to design a heating and cooling system that's sized properly. It's not too big, it's not too small. That makes it more efficient, but it also makes it more comfortable. And then once we've got to that stage, the process actually proceeds along pretty much like a normal home build would.
Well, now I want to talk specifically about this house. Let's start from the ground up. And it's so beautiful. Can you share with us some of the fixtures and equipment that you've implemented in this home?
Sure. There are a lot of really interesting, unique features in the house. It's fully electric, but some of the things we did is we have an induction cooktop, which is fully electric, and they're fantastic, very efficient. One of the really cool things we did is we have to meet a standard for delivering hot water to all the fixtures in the house. And so the bathrooms have occupancy sensors. So when someone walks into the bathroom, that sensor can tell that you're in there, and it turns on a pump that sends hot water to every feature in the bathroom. The other thing that's kind of interesting is we put in a sensor for the whole house, so you can watch in real time what every appliance is doing, and then you're a more informed, more engaged user of the home.
And how about the mechanicals in the basement?
The mechanicals in the basement are also all electric, and they're based on heat pump technology, which are extremely efficient. So we've got a heat pump to heat and cool the house, heat and cool the garage. There's a heat pump hot water heater, very efficient, and then a heat pump dryer.
Great.
Yeah.
Now, let's do a little show and tell. Can you tell me about the actual construction of the home?
Well, you know, I would love to. You know, we did a lot of really unique things. From the outside and inside, it looks like a normal home. So Todd and I have built like a mock-up or a model to be able to show people some of the unique features of construction.
Let's see it.
Let's do it. Okay, Megan, come on out to the garage and I'll introduce you to Todd Richardson. He's the home builder.
Hello.
Hi there.
Todd's kind of the expert on all of the techniques we use for building the house, so I'll leave you in his hands.
Great. Well, this is absolutely from the ground up. Can you explain to us what's going on?
You bet. So Jeff and I made this mock-up, and we thought, you know what, it would be a great visual for us to meet with customers and kind of go over the things that they can't see that's behind the walls, and this mock-up achieves that for us. So what we've done is we've just started from the ground up with this representing our footing. We did a capillary break across the whole footing. Why that's important is that stops vertical drive of moisture to go up into your upper members of your concrete and then up into your house. I know Jeff talked to you also about the vertical insulation on the exterior of the home, which is represented by the yellow foam here. It's covered up on the concrete all the way down to the footing and all the way up to the roof. And it is attached to the backside of our zip wall. So the zip wall already has a membrane sprayed across the front of it. I don't know if you've ever noticed Tyvek on the outside of the wrap on the outside of the house. This allows you to eliminate that. That is a nice feature. We don't have all the flapping in the wind and all that. And the zip has a nice flashing system that we're able to use on the seams, which stops any wind penetration and moisture penetration. So that's very nice. If we go around to the backside, it's pretty much just a traditional system from there. And then we're able to net and blow the 2x6 walls and do our normal insulation in there. But in combination, the two added together add to an R30. So that is very nice for us to achieve roughly around an extra 10 R value in our walls, and that's what we were trying to achieve with this. One other feature that I would like to point out is we did do a horizontal foam in the basement, all throughout the entire basement, which is giving us some additional R value underneath the concrete floor as well.
Is that under this concrete as well?
We did it in the garage as well as an experiment because we wanted to make this garage a little bit more efficient. We actually added a mini split in the garage as well. So that was one thing we wanted to try an experiment with, was in the garage. One other thing I can point out on the mock-up is it was a challenge for us to protect this insulation. What were we going to do to make it so that it didn't get chipped, beat up? And we used a system we found, and it was a sprayed on, almost concrete looking ephes stucco look. And we tested it with a weed whacker, to believe it or not, and it actually held up. So we wanted to protect this for the homeowners. We didn't want it we didn't want the yellow foam to stick out. We wanted to protect it. So, and you know, one thing too I want to talk about is some of the thermal bridging that this system helps prevent. So what I mean by that is you can see where this 2x6 stops, and we have an insulation portion in between the plywood and the 2x6. This insulation stops thermal bridging, and thermal bridging occurs when the 2x6 transfers, or the cold transfers all the way through the 2x6 to the interior of the home. And this insulation prevents that from happening.
Wow, with all of this construction, all of this science, Jeff, join me again. My big question for you is this home zero energy ready now? And if it's not, what have you guys done to get it to that point?
Well, the house was constructed with that in mind. The orientation of the roof, the square footage of the roof in that orientation. The solar company has been in contact with the electrician to make sure everything is in order so that can happen.
So really all this homeowner has to do is add a renewable energy source and they should be good to go?
Correct.
Wow. My last question for you, I'm sure there are a lot of people out there that are interested in this, but cost is always a consideration. Can you do a little cost comparison for us? What's the price difference between a home with this construction and what we would consider a traditionally built home?
Yeah, I don't think there's any question there's an added cost. The Department of Energy has estimated that if we meet all of their rigid standards, the increased cost can be about 5 or 6%. But we've also had a final HERS rating done, which was 38, and that suggests the house is about 60% more efficient than a standard home. And if that's the case, the annual savings is approximately $2,700 a year. So, over the lifetime of the house, you easily recoup that cost.
Well, congratulations to you both. This is a fabulous house. Thanks for sharing it with us. If you're interested in zero energy ready homes and energy efficient construction, go to our website, PowerHouseTV.com. Did you know the Home Energy Rating Index is a score that shows how a home's energy consumption compares to a home built to the 2006 International Conservation Code? Any score lower than 100 indicates a home is more efficient than the standard home. For example, a score of 80 means the home is 20% more efficient than the code home. A score of 120 means the home is 20% less efficient. The lower the number, the better.
In every powerhouse, we want to get the most use of spaces available to us. This can be challenging, especially if you can't maintain a comfortable temperature in certain areas. Here to walk us through some information about heat pumps and their function is PJ Cowell from Colony Heating and Air Conditioning. PJ, thanks for being with us. Most homes have a fully integrated HVAC system. What's a heat pump and why would I need to add one?
In layman's terms, a heat pump is virtually an air conditioner that runs backwards. So we have an outdoor condenser, and that outdoor condenser in the summertime blows the heat out or through it. What a heat pump does is it reverses that and it brings that heat indoors. And so we're using that heat and transferring that across the coil and using that to heat our home in the wintertime. The drawback to a heat pump in our climate is when the temperatures get down to 15 degrees or colder, that heat pump is going to struggle, A, not being efficient enough, and B, not transferring enough heat. There's not enough heat in the air to comfortably heat your home. So we need some sort of a dual fuel or a backup heating system, whether that would be an electric strip heat or a forced air furnace to help offset that.
So are there different types of heat pumps, PJ?
There's 3 different types of heat pumps. This particular system that we're looking at here is a air-to-air heat pump. They also make a geothermal heat pump, which uses the ground temperature, the 55-degree ground temperature, as its heating system. And then there's also a water source heat pump, which if, say, for instance, you had a pond, we could run loops through that pond and use the temperature of the pond to help heat and cool our home.
Okay, we're in a new construction, so talk us a little bit about the installation of a heat pump here.
This particular system has ductwork, just like a conventional heating and cooling system. We have a air handler here, and this air handler happens to have electric strip heat as our backup, and then we have a outdoor condensing unit.
Again, we're in a new home construction, but it can also be, I can put a heat pump in a retrofit, correct?
You can. There's these air handlers like what we're looking at here. We get in a lot of applications where, say, we have a 2-story home and it won't cool as well in the summertime. So we get in a lot of applications where we'll put this type of system in a 2nd story or in an attic and use that to heat and cool the 2nd story. Do a lot of these on room additions. What's nice with this type of technology is when we get in a room addition that's 600-800 square feet, we can't really put a forced air furnace in there, it's too big. So this type of application, we can get a unit that's 3/4 a ton up to 5 tons. So we got a lot of variables there, and we can get a system that fits the needs of that particular room. We can also take this and put this inverter technology and heat pump on an existing forced air furnace. Say for instance, if you had a gas furnace that is newer and your air conditioner is older, you could go to a heat pump in that type of application. This particular system, heat pump system, we have wall-mounted air handlers that can be put in. We have cassettes, they call them, which are ceiling-mounted units, and they make one that's a low wall unit. So we got a lot of options there with this same heat pump and inverter technology that we can hit different applications.
Okay, and I'm sure many of our viewers, we think about the heat pump and we think, okay, heat, but we also, it's used very much during the summer months for the cool, to bring cool to our house.
It is, and that's the biggest advantage of a heat pump and that this type of system is we're up in the 23, 24, 25 SEER rating that stands for Seasonal Energy Efficiency Rating. So a conventional air conditioner is going to be 14 SEER. This is going to be up in the mid-20s, so a lot more efficient.
Well, PJ, thanks for giving us a great overview. And as always, do your research, talk to the professionals, and see if a heat pump might be right for your powerhouse. The first heat pump was invented in Austria in 1856 by Peter von Rittinger. Modern versions of the heat pump became commercially popular for American homes during the oil crisis of the 1970s.
Can a house be sealed too tightly? Many experts say no. A tight home means it's energy efficient and free from air leaks that can impact your overall energy costs. Air quality can also be more easily controlled and regulated through green building ventilation measures.
If you've watched PowerHouse episodes, you've seen us conduct blower door and airflow tests on homes and refer to the HERS index, the Home Energy Rating System. In the ZERH construction we looked at earlier, one of the efficiency features they added was a whole house ceiling product called Aero Barrier. Matt Hoskins from Comfort Solutions is here to tell us more. Matt, thanks for joining us. Tell us about Aero Barrier, what it is and what it does.
Aero Barrier is a whole home air sealing system that uses blower door technology combined with an acrylic caulk and throws an aerosol mist into the air and air seals an entire home in less than a couple hours.
Now we're in a new home construction. You're getting ready to do the process in here, right?
Correct, yeah. We have a van sitting outside that's got a compressor and a generator so we can generate our own power and our own air pressure. And we hook that to a blower door, and then through a bunch of tubes we run to these sealing stations that have nozzles that will mix with a little bit of water with our acrylic caulk, and it throws that aerosol up into the air and then finds every little gap and crack following that blower door technology and pushing air to the outside envelope.
How long does this process take?
The setup and the takedown is usually about a half a day, and then depending on the size of the home, it goes anywhere from, I would say, 45 minutes to 3 hours.
Matt, we're in a new home construction. This process, can I go into an existing home and use this?
Yeah, absolutely. We have a number of applications that we've done over the years now. From bonus rooms, we do additions a lot of times, and now there's some new exciting technology where we can do attic-only seals, where we put the stations up in the attic and then we depressurize the home, and the air and the material pull through all the gaps and cracks between your ceiling and the attic and air seal from the top side down below.
Now I know as you're doing that process, you can watch it on a laptop, right? As the process is going, and you can see it, that it's really taking hold.
Correct. We have an MCU and laptop that actually control the blower door, can control every single station that we have, of how much material. We can monitor the pressures and the humidity levels, and the laptop will have a chart that will actually show us, as the seal is happening, how tight the house is getting. So we can set a goal and then hopefully hit it or even exceed it.
So you're sealing this house, again, keeping during the winter the warm air in, summertime keeping our cool air in, but there's also other benefits as well to this process.
Absolutely, yes. The AirBear product stops not just the heat transfer, but moisture transfer, which is one of the most important things that we're trying to do in a home these days, is to keep moisture out of your attic or out of your wall cavities. It helps with sound transfer, it helps with odor transfer, and even helps with pest control.
And the results are amazing when you talk about the air exchange. Explain that a little bit.
Yeah, absolutely. In the Midwest, we are held to energy code standards anywhere from 3 to 5 air exchanges, depending on what state you're in. The beauty of the air barrier product is we get the levels down below 1 in many cases, even sometimes 0.5 or below, even below passive house standards.
That's a tight envelope, right?
It is. It's a very tight envelope, and you're going to want to ventilate a house when you have this product, because we are going to make sure that the air exchanges are well within the ranges that need ventilation.
If I'm building a new house, do I talk with my contractor in terms of utilizing your product, or where does that come into the equation?
Yeah, when you're planning a house is the best time to be talking to your contractor about getting a hold of us. And getting us involved early helps a lot, especially with planning for those things like I talked about. Working with your heating and cooling company or insulation company to make sure that all the products that are going to work with air sealing are planned out accordingly.
I mean, the benefits, that we talk about on PowerHouse, energy efficiency and comfort go right along with your product.
They do. That's exactly it. And we always like to throw in durability and safety.
Okay. Well, Matt, thanks for sharing the insight on this. And if you'd like more information on construction and sealing up your home, go to alliantenergy.com or powerhousetv.com.
We hope you enjoyed this edition of PowerHouse.
We learned about the energy-saving nature of zero energy-ready homes.
We explored options and benefits of a heat pump system.
We saw a home sealing process that's truly a step above. Visit powerhousetv.com for additional information on energy-saving ideas and products. There are a lot of ways to improve your PowerHouse.